Welcome to New Breakpoint, Microsoft's digital event series designed for developers by developers. I'm your host, Michelle Sandford, the Developer Engagement Lead for Australia, New Zealand and Asia. We broadcast on the second Thursday of every month, and if you join us on the day, my guests and I will answer your questions live in chat. As you might know, New Breakpoint has expanded to encompass Asia Pacific, meaning we now bring interviews with developer experts from all over Asia. Today, we are welcoming Rakesh Lakshminarayana from Agile Insights. Rakesh is a principal architect. Hey, Rakesh, thanks for joining us.
Hi, Michelle. Thank you so much for the opportunity. I'm really glad I'm here today.
Cool. We're super excited to have you demonstrate what is inside AI Toolkit today on the show. But first, please introduce yourself and tell us about your role at Agile Insights.
Hey, everyone. My name is Rakesh, and so I have been working with Agile Insights now as a principal AI consultant. I have experience on Microsoft tech stack. And it's been 20 years now since I've worked on Microsoft technology. I started with the early days, web forms, VB coding, and now it's so exciting to start doing some new things like with the AI, and which has fundamentally changed everything, not just like what we build, but also how we build. But yeah, I'm really excited for this session today. Thanks again, Michelle.
Well, you and I are not strangers. We have worked together over the past few years. One of the ways we came together at the start was you were working at Insight with Daniel Fang, and the two of you were delivering our App in a Day Build AI Apps series into our customers, which was a really exciting project. And it's still ongoing, still being developed, but you're no longer at Insights. And the other thing was, we did AgentCon recently, and you ran one of the workshops for us, which was really cool. But today we're going to talk about intelligent apps, even, I guess, the next steps, the things that people need to know. So what would you say are the building blocks for building intelligent applications?
Yeah, so I mean, with respect to building applications, the generative AI applications, so a lot of things have changed. Actually, I have also made some slides on this. I'll just quickly share that on the screen, Michelle.
Mhm.
Okay, so what we have on so these are some of the key foundations for building intelligent applications. And we have actually looked at some of the things like language models, which is also a very important part of the intelligent application that we build. So picking the right model for the use case based on different metrics. I mean, the metrics could be like the performance, the cost, and also the capabilities. In some use cases, you may probably need multi-model support. So which means like you would probably look at audio and video or image processing. And in some cases, you would also require function calling. And based on your use case, you can go and pick the right model. And also you can use Azure AI Foundry, where you would go and browse through all the models. I'll show you the Azure AI Foundry shortly, but you have all the models from different vendors. And you can actually compare them against our various metrics on Azure itself. And prompt engineering techniques is all about crafting effective prompts to guide the model's response. And also you could share some samples of the expected format so that you are nudging the model in getting the right outcomes. And context management, what started as RAG, is now actually a critical part of the solution. So this is about managing the information that you provide to the model, and you would be fetching the data that's actually relevant for your user's prompt, and fetching the right amount of information is also the key. Along with the relevant information, because we obviously deal with the context size limitation, which means the number of words or number of tokens that we pass to the model is also something which we need to be mindful about. And tools, of course, this is like giving hands to the model to perform the actions. And there has been a lot of changes or a lot of improvements in the space. So what started as function calling now is actually being standardized into MCP tools, because each model would require a different way of probably calling the tools. And this is actually the standardization that we see in the MCP tool space. So, and also you could think about building agents. I mean, this is more about, and agents have been like the core of many intelligent applications. So this is basically about splitting your intelligent applications into smaller components and orchestrating the solution around that. So you could maybe think of a solution such as a travel itinerary planner. So where you can have maybe multiple agents working on different parts of the solution, maybe booking tickets, or maybe planning the holiday spots, and probably booking hotel. So you can actually think of this as a multi-agent solution. So where the user can go about adding the holiday plans, and there are multiple agents talking to each other in solving the problem. And there has been some improvements around how you orchestrate the multi-agents, and how do you actually share the context across multiple agents so that they work on the common problem. And yeah, so agent to agent communication, so where you reuse some of the agents out there already. And observability testing and evaluation is actually the key, which is normally ignored or maybe deferred to the later part of the project, but this is actually the key to success of any AI project. So and also the guardrails, so which means like you are building those guardrails around your AI application to make sure that the responses or the tasks that it performs is acceptable and falls within the safety limits as well.
So the context you provide for the model is very important. How do you go about doing this? What are the best practices?
Yeah, sure. Let me take you back in history a little bit. So, LLMs, like as you know, language models are a type of artificial intelligence that can actually understand and generate human-like text. And they can do this because they are obviously trained on vast amounts of data. And because of the ability to generate and understand human language, we started using them in some of the use cases like text generation, summarization, question and answering, and also translation. And we went a step beyond that and started building chatbots and virtual assistants that can interact with users in a natural way. And there were some shortcomings that we found along the way, things such as hallucination, where it could sometimes generate text that are factually incorrect, and not having access to real-time knowledge, and also context limitations, which means they can not probably process long documents or have access to longer conversations. So there is a limit to the data that you can actually pass to the model. And also inability to perform actions. So they can actually generate out text, but they cannot not maybe go and execute actions on the behalf of the user. And we started actually applying some of the techniques such as prompt engineering, where along with the instructions that you pass to the model, along with the prompt that you pass to the model, you would also add some instructions to control the model behavior. And you may also provide some samples of the input and the output so that the model can understand the patterns of your output that was generated and try to align its responses also along those lines. And yeah, so this is also where we started bringing in our own data to the model using something called retrieval augmented generation. So what started as retrieval augmented generation is actually the context engineering that we are talking about now. So in simple terms, retrieval augmented generation is about using the query from the user and trying to fetch the relevant data from your store. So we are able to do something called semantic search by using the embeddings of your user prompt and the embeddings of the data that is in your store. So we compare that using something called vector search. and we extract the actual the data that would be required for answering the user prompt. And we have to also be mindful that we extract only the limited set of data, so it falls within the context limitation that we have for the model. And yeah, so we pass the data that was extracted, which is the supporting data that you see on the slide, along with the other elements such as the user prompt itself and the system instructions and the samples. And the LLM would be able to generate a better response. And in terms of context engineering, so this is all about, again, like passing the right data to get good responses. And without the context, obviously, you get better responses. And without proper context engineering, the model may generate responses that are irrelevant or inconsistent. So your AI application needs to actually do three things at a very fundamental level. So it needs to actually keep track of the conversation history so that it maintains the coherence, it maintains the flow across multiple interactions. And it also needs to ground responses, which is using the external knowledge or your data to improve the accuracy or the relevance. We spoke about RAG. So RAG also falls under the context engineering space. And it might also be required that your AI application should remember the user's preferences so that it can be most personalized experience. So you would actually store this in three categories of memory. So it's called a short-term memory, a long-term memory, and your external knowledge. So short-term memory is where you would actually store the recent messages or the recent conversations in that thread. And the long-term context is where you would actually store the user preferences, the past interactions that you had, so that you get a personalized response from the model. And external knowledge is coming from the RAG. And here in this slide, I have actually included all the types or different types of data elements that you can actually pass to the model. Instructions, we spoke about it as a part of prompt engineering techniques. User input is the actual input that comes from the user. Examples, so that it understands the format and generates the output similar to your requirements. Data, we fetch from RAG, and metadata is actually the data that you would additionally pass to control some of the personalized experiences. And tool definition, you can actually include one or more tools, which tools can be of two types, knowledge or action tools. So this is actually the knowledge tools that we are referring to here, which can go and fetch data as well. And schemas. So we didn't talk about schemas. Schemas is when the model is generating the responses, it can actually generate the responses in different formats. You can actually provide the samples of it, but to enforce it, you provide schemas so that the model can generate the output in that format only, the JSON schema that you provide, so that you're able to use that data and feed that into the next step in your application. So you can align, or your AI application can actually align to that schema when it's supposed to be maybe automating something. So it gets the input in that format only. And history, of course, like it's actually the past interactions that we had, which would also be passed to the model. So there is a coherence, there is a flow in conversation. And yeah, so this is all about context engineering. So there's a lot actually that's happening here.
So when I'm explaining to people, I always make it sound so much simpler than it really is. I always just say, oh, well, from the prompt engineering, you need to just tell the app what its purpose is and tell it if it doesn't know the answer, it cannot make it up, and tell it that it can only go to the company data sources for its information. And then, ground it in that company data source, but then also set the temperature to 0 so it has no flexibility to make things up, and it has to only go with facts, get it to quote its references, and basically that's the basis for it. But what you're showing here is there's lots of other extra things that you can that you can use to really nail it down and make sure that it is following the purpose that you have set it to, and that it is that it is constrained, I guess, into producing what you expect it to do. That's much more than than I ever talk about. I love that. You use tools to extend the capabilities of the models, and there has been a lot of progress recently on using MCP tools. What problems does MCP solve?
Yeah, sure, Michelle. I mean, yeah, so to understand the actual advantage of using MCP, so we probably want to focus or realize like the shortcomings of the function calling. So let me just pull this other slide that I had quickly so that we understand how the function call works here. Yeah, so function calling. So this is where we extend the capability of your AI model by also providing the option to call your functions. So this goes in your input for the AI model. So when I say tools, so it's actually the definition that you pass. So which is the name of the method, the parameter that it accepts. And when you actually pass this along with your user input and other elements that we saw earlier, the LLM will actually make a decision whether it actually needs to call a tool and based on the list of tools that you provide. So it can actually do this because your tool names will be descriptive, and also you can pass additional information about what your tool does and what your parameters are about. So that, I mean, LLMs are good actually in understanding human text, so it can actually make this decision and come back with a response saying, I now need to call this tool, and this is going to be the parameters that would be required to call the tool. And then your application has to orchestrate this part, which means it would actually take the inputs or the output from the model, execute the call, and get the response, and again feed that back to the model. So now you have the original user query, you have the output of the function call that now goes to the model, and then you get the next response from the model. And this has been how we were orchestrating the function calls. And different models have different ways of calling the functions. So which means let's look into this example quickly. So this is the function call for getting the weather. So where I'm passing the details or the definition of the function to get a weather, and the question is, what is the weather at Melbourne? And we can see here that once you actually pass this to the language model comes back with the response saying it's a tool call, and getting the weather is the function that I would like to execute, and this is the parameter. And it would go, your AI application here would go and execute the function and return the response. And now you would see all the previous interactions and also the response that says our temperature is 24. And now the language model has access to all this data, and it comes back with the response that says it's currently 24 degree Celsius at Melbourne, which is not usually the case in Melbourne. But yeah, I just put it to make myself happy. But yeah, so let's actually look into the problem here. So with the function calling, each model calls the function differently, and not all models have the ability to call functions. So we want to standardize this part, or if we go along the path of adding or supporting functions for each models, we will end up with what's called M into M connection. So where M is the number of models and N is the number of tools that you want to support. So the number of integrations that you would end up writing is M into N, and which is a lot. And MCP actually tries to solve this problem by providing a standard interface in which the models and tools can interact with each other. So you would actually implement a tool just once according to the standard interface, and which means like it would reduce the number of integrations from m into n to m plus n. So you can see that there is a big advantage there in using MCP. And to go a little further into what MCP actually is. So these are your key elements or key components when you are using an MCP tool. MCP host is your application, is your AI application. So it could be an application that is interacting with a tool, maybe to fetch some data or something. So MCP client is the component that maintains the connection between the MCP server and obtains the context from the MCP server for the host to use. So MCP server is actually the server which implements the tool, and it implements the MCP interface and provides access to the tools and the data sources. And MCP server is responsible for executing the tools and returning the results to the MCP host. And in this slide, you can see there are like some samples of MCP tools that are for getting details from your local file system, or interacting with SQL databases, or maybe even making a REST API call. And the data or the resources that you can actually get from an MCP tool would be maybe knowledge-based tools like the resources, or it could actually go and execute actions as well. And it could also return some prompt templates. And I'll just quickly summarize the advantages that we would see in MCP in using MCP tool. So you would actually have an advantage of using a standard protocol, which means building and maintaining custom integrations using a consistent and scalable approach. And if the vendors, I mean, when I say vendors, so you would probably be using MCP server for interacting with GitHub, maybe. So GitHub has its own APIs. And there is also an MCP server for interacting with GitHub API. So if there is any change in GitHub API, so the vendor, I mean, like in this case, it's GitHub again. So they would also change the MCP layer. They would make sure that it's actually aligned to the changes that's in the API as well. So which means as vendors evolve their APIs, the MCP abstraction layer will also ensure that integrations remain stable and maintainable. So it's taking that load away from you. And it's plug and play integrations, which means like there are so many MCP servers that are built by the community and also by the vendors that you could readily use within your application. So you don't need to build these integrations from scratch on your own always. And of course, like reusability, and you are actually avoiding these custom integrations, which can be brittle and which can break over time by using what's already out there. And you can also centralize the access by centralizing the access to these MCP servers. You can build governance and security controls around it, so that for all the integrations that go through the MCP servers, you can actually have more control in terms of the security aspects, the governance, and also the auditing part of it.
So there's all these MCPs that, as you say, GitHub's created one, Azure has one, that have been created all over the place to help us with all of these things. Are they entirely trustable? Can I just, use it without thinking about it, or is might they not all be trustable? I'm just wondering, like with NPM and Node, and sometimes people are introducing things into extensions that they build in open source. Can we trust MCP always?
Yeah, so that's a great question, Michelle. So there are a lot of sites like I mean I did also come across the GitHub repository where all the popular MCP servers were listed. This is actually from the Model Context Protocol repository only. If you go, I'll post the link on the chat shortly. But so that's one place like where you will find some of the servers that's also built from community. It's more like a registry of all the MCP servers.
Hmm.
But this came out last week. I think it was on 15th of September from GitHub in one of the blogs, like where GitHub also started hosting an MCP registry, and this MCP registry is mainly targeted for VS Code, which you could use. I mean, I'm sure like we have used MCP servers in VS Code, so where you can actually attach them as tools for maybe talking to Azure or maybe interacting with GitHub. But this place, like, is the MCP registry in GitHub is like where you can actually go and find all the servers, all the for the VS Code on itself. So on this slide, you can see there is also this install MCP server button, and when you expand it, it actually gives you an option for installing VS Code, so which opens VS Code, and you can actually just go there and start interacting with it.
So take them from a trusted repository is the
Yes.
easiest way to be sure that what you're using is a trusted source, and
Yeah.
then it should be okay, because they're going to make sure that if there are any security vulnerabilities introduced, there will be fixes produced for that very soon.
Yeah,
Cool.
that's right. Yeah. So things have been moving so fast, so it's actually good to have like the tools from a trusted source so that I mean you have that ticked, I guess. Yeah.
Yeah, cool. Well, I think that what we're seeing here is that there's really a lot of moving parts when we are building intelligent apps, and the responses from the models, it might still not always be predictable. So how do we go about testing and evaluating those applications? I think that's the logical next step, right?
Yeah, yeah, that's right. That's a good question. Michelle. So, I mean, it's often ignored in terms of like the observability part and the evaluation parts, but that's actually the key criteria for the success of the AI application. And observability is probably about logging as much as you can. Like when you're not, when your application is running, it could be the prompts that's been sent, the response that you get, like the data that you actually retrieve from your knowledge bases and what's fed into the model and how many tokens were consumed. So all this is actually an important information that you would capture and then like analyze to make your AI application better. So I would also like to actually highlight that AI Foundry yeah, I would like to also add that AI Foundry has made it very easy for developers. I mean, this is actually the missing piece, like where you have threads, like, I mean, these are the messages that goes into the model, and you would need visibility in terms of what tool calls were made or what actually data was returned from your tool call or extracted from your knowledge bases. So you can actually go to AI Foundry and step into the thread that was executed, and you can actually see the history, like have access to all this. And you can also see here that when I actually click on the tool, it shows me what data was returned from the tool as well, which is really important. Like when you're trying to troubleshoot why your model is behaving in a certain way or why your AI model is not actually executing the task, you can come back and have access to all the steps that you could troubleshoot. Yeah, so going back to the question about evaluating the AI application, I would also like to highlight the three stages of the evaluation steps. So, yeah, so the AI application that we build is actually can be evaluated and managed at three different stages. So at the very early stage, so this is where it's critical for you to select the right model. So the model that we would select is obviously based on the use cases that we are working with, and we would maybe look at various metrics such as quality, accuracy, cost, and performance to decide on the model that we want to use. And we would also run maybe some evaluations. And again, like Microsoft provides some evaluators that we could actually use for maybe running the models with your data or maybe the public data sets to understand the responses and then decide which model to start with. And the pre-production evaluation is the next step here. So we have actually developed the application, and it could be a chatbot or an agent or any other AI solution. And now it started to produce responses and maybe execute tasks as well. And now it's time for us to understand whether it's up to the mark that we expect. So this is a very important stage, and here you can actually again bring your own data sets or the public data sets to evaluate your application. And what you do here is like again use the evaluators that AI Foundry or Microsoft provides. And in the next slide, I'll be showing you what those evaluators look like. I mean, you would be maybe covering a broader set like the quality, the coherence, the accuracy, and also safety and security aspects of it. And if you're also using agents in your solution, you would evaluate if the tool call was made, if the task adherence was there. So you can actually track all this and then decide on where exactly the improvement would be necessary, or whether it actually meets your quality expectations. And there is also something called AI red teaming agent, which can simulates, which is a kind of evaluator, and it can actually simulate complex queries across a broad range of security and safety scenarios. So if you don't have your data and you want to simulate something, you can use AI red teaming agent to simulate some of the security and the safety scenarios so that you are able to identify and catch those vulnerabilities upfront in your project. And the last stage is the post-production monitoring. So this is where you continue to monitor your application and continue to measure your key metrics. And this goes as a feedback for you in improving the application. So just to summarize, like what we do in a pre-production evaluation. So you select the target. So you select the models and the data sets and the application endpoints, and you prepare the test data. So this could be your own data, or you could actually bring the data from the public data sets, and it all depends on your use cases. Or you could also simulate the data using simulators that's available on Microsoft. And then you would select one or more evaluators. And here on the slide, you can see that there are some evaluators that are available from Microsoft. You can also build your own custom evaluator. And so these, I will not probably go through the entire list, but this is mostly about checking the metrics on coherence, fluency, and also if you are retrieving data from your external knowledge bases, you would maybe look at document retrieval and whether the data was grounded as per your expectations. And if we are using agents, we probably be looking at metrics around whether the intention of your user query was processed accurately, and whether the tool calls were made as expected. And once you have selected the evaluators, then you would run your evaluation. So again, like you can actually run your evaluation on your local environment, or maybe you can actually build a CI/CD pipeline if you want to run this more regularly. And as an outcome of this, you would actually look at maybe creating a baseline for your AI application, or maybe comparing it with the previous runs to identify the potential degradation or understand the improvements, and then maybe go back and like fine tune some of things such as maybe do more prompt engineering, or maybe extend your RAG implementation. And yeah, so that's the kind of actually steps that you would probably take to achieve the desired outcomes or the results that you would expect for your AI application.
Oh, that's cool. I think we should just like get into your demo now and have a look
Yeah,
at what you've built.
yeah, sure, Michelle. Thank you. Yeah, so I built an AI assistant for fictional Contoso bike store. I mean, this actually can answer questions related to maybe the bike models and accessories that are in stock. And also, it can help answer queries about orders. And this is the UI that I built that you see on the screen. And actually, I'm not a front-end developer, so I had to rely on my good friend, GitHub Copilot, to get this UI up and running. And it did an amazing job. And like I've been using it so much now. So it's not just me typing, but I can also point it to some references, screenshots, and it can actually do something very close to it. So I'm really impressed, and I can't wait
So
to see like the progress. So I actually built this AI assistant like for a fictional Contoso bike store using Copilot. And so what actually this does is it uses MCP tools in the background. So we'll be talking about how the tools were built and what is the architecture. I would probably just show a quick demo of this application. So it's very straightforward. We also have some prompts or ready-made prompts here that we can actually click. And I'm inquiring about the available bikes that are in Contoso store. Yeah, so now actually we can see the response from the agent. So it lists the details in a good format. So we can see the price, the features, where the bike stores are. And now maybe let's try something else. Let me maybe ask about the order. So, I mean, we don't have a database a link to it. We'll see how the data is managed at the backend. So the order ID wouldn't really matter. So I've just typed an order ID that says 12345, and the agent will again go and call another MCP tool to fetch the order information. And let's see the response. Still working. Yeah, there we go. And it's come back with the details of the order. And unfortunately, this has been delayed. And we also have some information about the steps the order has actually gone through, received, confirmed. And yeah, so this is again coming from an MCP tool. And yeah, the next step that I would also like to show is the architecture
Mhm.
of how this is built. Let me just bring up the slide. Yeah, I would like to also talk about the architecture of this application that we have for yeah, the agent. So the UI is built using React and it's hosted on App Service, and the backend is a .NET Core API. And the backend is actually the chat orchestration, has the chat orchestration logic, and it integrates with Azure AI Foundry for running the agent. The agent that we have, the Contoso agent, is actually running from Azure AI Foundry. And this agent has access to built-in tools and also the models that's available in AI Foundry. And for our use case, we are using GPT 4.1. And we also have an MCP server. So which is for fetching the product inventory and also for managing the orders. And the MCP server uses the product inventory REST API, which is again a .NET API. And this is normally how we expose MCP servers on an existing API. So let's assume that the product inventory REST API is something that was existing for the Contoso store, and we are building an MCP server on it so that we are able to use that in our agent. So that's normally the kind of use cases that we see with the customers. And so right.
This
So
this
now
makes it look very simple.
right, yeah. Actually, it's simple. I mean, when we are working on Azure Stack, so they do a lot of heavy lifting in terms of the agent communicating with your MCP server tool. So a lot of things have been taken care by Azure, and also the observability part, which we see. But I mean, for me, it's more like Lego blocks, I guess, like joining the dots or like building the blocks together and tying them together to build your solution. But yeah. So let me just quickly go to AI Foundry, and we can actually see the recent interaction uh, that we did on our AI assistant. So this is actually the portal, and if I look at agents, so this is the agent that we created for our application. It's called the Contoso Backstore agent. And if I click on it, you can see the instructions that were given to this agent, and also the tools that it has access to. And in our case, we are only using an MCP tool. And if I actually go to my threads, this would be ordered. You can actually order it. So you can actually go to the recent thread. And this is the question that we asked. And you can see the response that came from the agent, and maybe you can continue looking into more details of this thread by clicking on the Stride Playground button. And you can see how much tokens were used, what tool calls were made. And the best part is the thread logs. So when I click on thread logs, so this is where you would actually see the step-by-step execution. And when I click on the MCP tool, you can see the data that was actually returned by the call to the MCP tool here. And this is a big time savior. I mean, like when you're troubleshooting an issue, so you would need access to this level of information. And yeah, so the next thing that I had was how this MCP server was actually implemented. So let me just bring up my Visual Studio. So as we saw in the presentation, so we have a chat orchestrator API, and the chat orchestrator API is talking to an agent, and the agent has access to the MCP server, which actually talks to the product inventory REST API. So we are looking at focusing on this part of the solution to understand how the MCP server is built. Yeah. Yeah, there we go. So I've just opened the implementation for the MCP server on VS Code. So we are actually focusing on looking at this part of the solution. So where the chat orchestration API will call the AI Foundry agent, and the AI Foundry agent has access to the MCP server. And MCP server uses the product inventory REST API to fetch the data it needs. So we are looking at how the MCP server is implemented. And yeah, so this is a .NET Core API, and excuse me. And as you have seen, as you have already heard me saying several times about MCP, so this is actually the protocol that all models can understand. If I expand this, so this looks like a normal .NET Core API that we built. And if I open the program.cs file, you can see this step where we are registering the tools called the product inventory tool and the order management tool. And I've also added authentication here. So, I mean, it's actually like any other API, and you could probably use API key-based authentication, or maybe you can use OAuth based on your policy and enterprise requirements. So I've actually configured API key authentication for this MCP server. And let's actually look into the tools. So to start with the product inventory tool. So these are nothing but simple class files with the attribute that says MCP server tool type. And this is coming from a framework. If I open the project file here, this is coming from a framework called Model Context Protocol, and this library is still in preview mode. But I mean, we can actually start experimenting with this now. Product inventory tool, and for each of the tools that you want to expose, you would actually add this attribute and a good description about what the tool would do. And yeah, so in here, the implementation is simple as calling an external API, which is another .NET Core API that's also hosted on app servers. You get the data and you return that as a JSON format. So all the magic is in terms of the data that is presented here in a nice format is from the model. So we are returning the JSON data from your MCP server, and the model uses that JSON data and formats it to answer the user's question. And the best part of MCP or VS Code here is you can actually also start interacting with it using the Copilot. And if I just close all this and show you the configuration that we have. Sorry, this is just open the main project where I have the complete source code. So it's easy for us to actually interact with it. And if I open VS Code, I can go to mcp.json file, and I have registered the MCP server that we built for the Contoso backstore, and I've also added an API key. So you can actually manage your authentication configuration also while you are registering the MCP server in VS Code. And now I can actually ask the same questions that we did on the AI assistant UI. So let me just quickly grab the question so that I don't have to type the whole thing again. So, right, okay. So let me just add that. I'm just checking if the tool has been registered. You see a warning that says like there are a lot of tools that I'm using, and it's not a good idea to have too many tools. Yeah, so there we go. So we have the Contoso bike store, and we have these tools that are ready, that are available. And let me now click on OK. And yeah, so you also have to actually check if the tool is running or not. So this is probably making the Copilot chat aware of these tools. So let me just click on restart. So it changes to running state. And now let's send the prompt. And yeah, so it says used one reference. Yeah, so it's able to detect the tool, and it's asking for the approval to execute the tool. Zoom in a little bit. And I can see this a similar response. And yeah, obviously it depends on the model that you choose. So I have cloths on it active, so it might actually present the results in a different format. But yeah, you can actually see the list of all the bikes that's actually coming from our MCP server. Yeah, and
So many bikes.
yeah, so that's more descriptive than what we saw on the agent in the browser.
You know what? You think it's the model? Because I do not I like Claude 3.5, and I know there's 3.7 and there's 4 after that. And the reason why I'm picking like a lower model, an older model, is because I find them to be less verbose, less like the newer the model, the more it seems to want to like give you all the information possible, all of the features, and it's just like making such a big deal about everything. And I'm just like, calm it down. Let's just And so
Yeah,
yeah, I like 3.5 over 4.
yeah.
I
This
do
is
like
the
the Claude
simpler
ones.
version.
The GPT ones are good.
Yeah, that's right, Michelle. This is the simpler version. I just changed it to GPT 4.1, and like you can just see the summarize table,
Mm.
just as you said. But yeah, I mean, some of these models can actually go a lot deeper in terms of doing more research, and the data that you get can also be more than what you were after, I guess.
Yeah, I mean, you have to weigh these things up because obviously it's using more tokens when it's
Mm,
doing all that extra work. So it's
yeah.
less efficient overall, and for me, slightly more annoying.
And yeah, so that was actually the demo for the agent that's using MCP server. And
Cool.
yeah,
Okay, so thank you, Rakesh, for your demos. I think they've provided amazing insights today. I know we could have carried on doing more and more and talking about all the different parts of it and never get bored. But I do think that you've probably given our viewers a few ideas about how they can use AI Toolkit in the real world to build their own applications. We're going to link all the resources from this episode into our GitHub blog. Just to finish off, tell me, what do you think is the future of intelligent apps? What are you most excited about?
yeah. So I mean, there's a lot going on, and things have been actually progressing so fast. So now, like things that we build custom are becoming part of the model that we use itself. So it's actually interesting to see how the future would progress, and I would probably be looking at things being more deterministic and like things being more in control, and also focus on the tooling side of things. Like that's where like it's probably the brain is the model, and the tooling is like the actions, I guess. Like, I mean, that's where I would be looking at, be more excited about building new capabilities, I guess.
The tooling is the arms of the Octocat.
Yes, yes. Yeah, that's right.
That's awesome. Okay, so during this episode, Rakesh and I have been answering questions online, and we'll stay online to answer them for another 10 minutes or so. But anyway, thank you for joining us, Rakesh. This has been an amazing episode, and we look forward to seeing you all again next month. Thanks, Rakesh. Thanks,
Thank,
everyone.
thank you so much, Michelle. Thanks, everyone. Yes.
We hope you enjoyed this digital event. We have specialists on standby to answer your questions for a short while. To ask a question, type it into the chat window now and we'll get to it as quickly as we can. If you're not staying for the Q&A, thank you for attending and we hope to see you again soon.